Hello everyone, so in this video I'll be explaining to you about relationship between the nearest neighbor distance d and radius of atom r and the age of unit cell A for pure elements. So the first one is the simple cubic. In a simple cubic arrangement, the atoms at the corners touch each other, as you can see in the figure. They are touching each other. Therefore, distance between the nearest neighbors, which is D, is equal to AB, and AB is equal to A. So the radius will be equal to A by 2. The second one, face-centered cubic. In a face-centered cubic arrangement, the three atoms along the face diagonal touch each other, as you can see in the figure. Therefore, distance between the nearest neighbors, okay, so we have to consider between two atoms only. Okay, now along the diagonals there are three atoms, but then we shall consider of the two. So along AC, if we divide into 2 equal half, alright, so we have to consider only two atoms. Therefore we get D equals to AC by 2. Now in right angle triangle ABC, where AB is equal to A and BC is also equal to A, by applying Pythagoras theorem we have AC square equals to AB square plus BC square. AC square equals to A square plus A square is equal to 2A square. Therefore AC equals to root over 2 into A. Therefore we have D equals to AC by 2. So instead of AC, we substitute the value of AC, which we get as root 2A by 2. And on rationalization, we get A by root 2. Again, the radius of an atom or the atom is equal to D by 2, which is equals to A by 2 root 2. Let us see how we get R equals to D by 2. You see, we have already deduced the value of D, which is equals to AC by 2, which means along the diagonal we have divided into two equal parts by dividing it by 2. Then D is the half portion of the AC, where the center atom is divided into two equal parts, and all these three atoms are in contact, where the center point of the atom at point C and the center point of the atom which is present between A and C are in contact with each other, and therefore they give the radius of the two atoms. So which means the radius of the atom present at point C and also the radius of the atom present between A and C. So which is equals to 2 times of the radius. And therefore, in order to find the radius of only one of them, we have to divide it by 2. Therefore, we get R equals to D by 2. The third one, body-centered cubic. In a body-centered cubic arrangement, three atoms along the body diagonal touch each other, as you can see in the figure. Therefore, distance between nearest neighbors, D will be equal to AD by 2. Now in right angle triangle ABC, we have AC, by Pythagoras theorem, we have AC square equals to AB square plus BC square, where AB is equal to BC equals to A. So AC square equals to A square plus A square, or AC equals to root 2A. Then in right angle triangle ADC, by applying Pythagoras theorem, we have AD square equals to AC square plus DC square. Here AC is equal to root 2A and DC equals to A, which is the side of the cube. So AD square equals to root 2a the whole square plus a square, which we get as 3a square. Therefore AD is equal to root 3a. Now the nearest neighboring distance we have is d equals to AD by 2. So we know AD equals to root 3a. So therefore d equals to root 3a by 2, and the radius will be half of the d. So r equals to d by 2, which is equals to root 3a by 4 after calculation.